Good morning all. Today we are going to discuss numericals on friction. So now a body of weight 70 Newton is placed on a rough horizontal plane to just move the body. A push of 20 Newton inclined at 20 degree to the horizontal is required. Find mu. So here the figure is not given in the question. So you have to draw the figure. So a block of weight 70 Newton is resting on a horizontal floor or a horizontal surface. So now a push of 20 Newton. So push means this is the direction of force. Push required is 20 Newton and its inclination with the horizontal axis is 20 degree. Weight of the block is 70. So now the first step is you have to draw the free body diagram. So in the free body diagram you have to remove the block from all its connections and you have to draw all the forces acting on the body. So here 20 Newton is a push. So the x component, this is your x-axis and this is your y-axis. So x component of this force is 20 cos 20 degrees. So angle is made with x-axis. Horizontal component is 20 cos 20 degree. And now the vertical component. So this is the vertical component, direction is downward. So the vertical component is 20 sine 25 degree. So now the weight of the block is acting downward, that is 70 Newton. So there will be reaction exerted by the surface. Reaction is represented as capital R. So now due to the push, the body has a tendency to move towards the left. So friction is acting towards the right. F is equal to mu into R. So now these are the forces acting. So now you have to apply the equations of equilibrium. First equation of equilibrium for a concurrent system is sigma Fx is equal to 0. Second equation is sigma Fy is equal to 0. We have to start with this equation. All the vertical forces are equated to 0. These are the vertical forces. Capital R is acting upward. Minus 70 minus 20 sine 25 degree is equal to 0. So here in this equation you can write R is equal to 70 plus 20 sine 20, this angle is 20 degree. So that is equal to 76.84 Newton. So now the second equation is sigma Fx is equal to 0. You have to take all the horizontal force. So F is acting to the right. It is positive. F minus 20 cos 20 degree is equal to 0. So F is equal to mu into R. So mu into R is 76.84 minus 20 cos 20 degrees equal to 0. So mu is equal to 20, you have to take to the right side, 20 cos 20 degree divided by 76.84. So 20 cos 20 divided by 76.84. So that is 0.244. So it's a unitless quantity. So now the second question. So here a pull of 20 Newton inclined at 25 degree to the horizontal plane is just sufficient to move a body placed on a rough horizontal plane. Thus the push required to move a body is 25 Newton inclined at 25 degree. Find the weight of the body and mu. So here a pull of 20 Newton inclined at 25 degree is required to move a body. That is the first case. Second case, a push required to move the body is 25 Newton inclined at 25 degree to the horizontal. You have to calculate the weight and the coefficient of friction, mu. So you have to consider two different cases, case 1, then case 2. So in the first case, a pull of 20 Newton inclined at 25 degree. So the first case is pull of 20 Newton. So this is a pull 20 Newton inclined 25 degree to the horizontal. That is case 1. In case 2, the same block is applied with a push inclined at 25 degree. So these are the two different cases. So now you have to draw the free body diagram. So in case 1, this is your x-axis and this is your y-axis. So weight is assumed as W. Now the components of 20 Newton along the x direction is 20 cos 25 degree. Angle is made with x-axis. X component is 20 cos 25 and the y component is 20 sin 25 degree. Now there is normal reaction. You can assume it as R1 for case 1. So here, due to the external force in this direction, friction is acting in the opposite direction. F1 is equal to mu into R1. So here you have to write the two equations. First equation we are taking is sigma Fy is equal to 0. So R1 minus W plus 20 sin 25 degree is equal to 0. So R1 is equal to W minus 20 sin 25 degree. So now the second equation is sigma Fx is equal to 0. So you have to consider the forces in the x direction. So 20 cos 25 degree minus F1 is equal to 0. So now from this equation F1 is equal to 20 cos 25 degree. So 20 cos 25 degree, that is equal to 18.125. Sorry, 126 is equal to 18.126. So similarly you have to draw the free body diagram of case 2. So here this is your x-axis and y-axis. Then x component 25 Newton is making 25 degree with the x-axis. So x component is 25 cos 25 degree and y component is downward 25 sin 25 degree. So you have to resolve along the x and y axis in the first quadrant. So direction is towards left and y component direction is downward. So here the reaction is assumed as R2. So since this is the direction of force, friction is acting in the opposite direction. F2 is equal to mu into R2. Then weight is acting vertically downward. Weight is assumed as W. So here in case 1 and 2, mu is same because the surface is same. So in the second case, you have to assume the first equation as sigma Fy is equal to 0. So R2 minus W minus 25 sine 25 degrees equal to 0. So R2 is equal to W plus 25 sine 25 degree. Second equation is sigma Fx is equal to 0. So in the second equation, F2 minus 25 cos 25 degree. F2 is acting to the right, 25 cos 25 degrees to the left is equal to 0. F2 is equal to 25 cos 25 degree. So that is equal to 22.65. 22.658. So now you have to divide this equation, that is, from the first case, mu is equal to F1 by R1, and the second case mu is equal to F2 by R2. So you have to write the equation for F1. F1 is equal to 18.13 divided by 3 divided by W minus 8.45, and the second case mu is equal to F2. F2 is 22.658 divided by R2. So R2 you have to simplify from this equation. R2 is equal to W plus 25 sine 25 degree. So 25 sine 25 degree, that is 10.57. So W plus 10.57. 10.57. So you have to equate the equation 3 and 4. So 18.13 divided by W minus 8.45 is equal to 22.658 divided by W plus 10.57. So on solving, you will get the value for W as 84.55 Newton. So here you have to cross multiply this two equation. So 18.13 into W plus 10.57, that is equal to 22.658 into this term, that is W minus 8.65. So W is equal to 8.55. So now the third question. Two blocks A and B of weight 1 kilonewton and 2 kilonewton respectively are in equilibrium position. If mu between the blocks as well as the block B and the floor is 0.3, find the force required to move the block B. So here you are given connected body. Two blocks are provided. First block you can name as A, second block as B. So here you have to draw the free body diagram of both the blocks separately. So first we will do the analysis of block A. So free body diagram of A. So the block A is connected with a string. So tension is developed inside the string. You have to resolve the tension along the x and y direction. So this is your y direction and this is your x direction. So component of tension along the horizontal direction is T cos 30. 30 degree is made with x axis. So component is T cos 30. Tension, it is acting in this direction. So when you resolve it along the x direction, the force is acting towards the right. So this is the direction, and when you resolve it along the y direction, it is acting upward. So tension T cos 30. Sorry, this is T sin 30. So now weight of block A, that is 1 kilonewton, that is acting downward. And there will be reaction exerted by block B. This is represented as RB. So this is the direction of movement of A. So friction is acting towards this direction. This is FA. So now you have to write the equation of equilibrium. First equation we are using as sigma Fy is equal to 0. So RB minus 1 kilonewton. 1 kilonewton, that is written as 1000 Newton, plus T sin 30 degree is equal to 0. So RB is equal to 1000 minus T. Sin 30 is half, T by 2. So now the second equation is sigma Fx is equal to 0. So here T cos 30, then minus Fa is equal to 0. So Fa is equal to T cos 30, that is equal to 0.866 T. So now Fa is equal to mu, 0.3 into RB. So here the reaction is RB. So Fa is equal to 0.3 mu into this reaction, that is RB. So that is equal to 0.3 into RB is 1000 minus T by 2. That is equal to 0.866 T. So on simplifying this equation, you will get T as equal to 295.28 Newton. That is the tension developed along the string. So now you have to calculate Fa is equal to 0.3 into RB. So here RB is equal to 1000 minus T. T is 295.28 by 2. That is equal to 1000 minus 295.28 divided by 2. That is equal to 852.36. 852.36 Newton. So Fa is equal to 0.3 RB, 8652.36. So that is equal to 255. 255.7. 255.7 Newton. So now you have to take the second block. So for the second block, capital R is the normal reaction that is acting upward. This is the x-axis and this is your y-axis. Normal reaction is acting upward. So weight of the block is given as 2000. That is 2 kilonewton is equal to 2000 Newton. So now there is reaction exerted by block A. So we have assumed the reaction as RB, that is acting in the upward direction. So same reaction is acting downward. So now here the external force is given as P. So friction, according to this P, body has a tendency to move to the left. So friction developed at the contact surface on bottom and top will be acting towards the right. This is FA and this is FB. So FB is equal to mu. Mu is 0.3 into R. So here FA is equal to 0.3 into this reaction, that is RB. So now these are the forces acting. So first equation you have to use is sigma Fy is equal to 0. So capital R minus 2000 minus RB is equal to 0. So R is equal to 2000 plus RB. So RB is 852.36. So that is equal to 2852.36 Newton. Second equation is sigma Fx is equal to 0. So Fa plus Fb minus P is equal to 0. So P is equal to Fa, it is 255.7 plus Fb, that is equal to 255.7 plus 0.3 into R. So that is equal to 255.7 plus 0.3 into R is 2852.36. So this is equal to 1.41 Newton. That is equal to 1.1 kilonewton. So now the next question, a block of weight W is placed on a rough horizontal plane as shown in figure, and a force P is applied at an angle theta with the horizontal such that the block tends to move. Prove that the force P will be least if the angle theta is equal to angle of friction. So here the figure is given in the question. First step is you have to draw the free body diagram. So here this is your x-axis and this is your y-axis. P is inclined at an angle theta with the horizontal. So x component is P cos theta and the direction is towards the right. And the vertical component is P sin theta, it is upward. So P sin theta. Weight of the block is assumed as W, and there will be reaction exerted by the surface, that is represented as capital R. So this is the direction of movement of the block. So friction is acting towards the opposite side. So now you have to use the first equation, sigma Fy is equal to 0. So capital R minus W minus plus P sin theta is equal to 0. Second equation is sigma Fx is equal to 0. So from the first equation you can write R is equal to W minus P sine theta. That is your first equation. Second equation is sigma fx is equal to 0. So P cos theta minus F is equal to 0. So F is equal to P cos theta. That is your second equation. So what is F? F is mu into R is equal to P cos theta. So now you can write mu is equal to P cos theta divided by R is equal to W minus P sin theta. W minus P sin theta. So this is equation for mu. So now you have to cross multiply this equation. So on the right side P cos theta, and here you have mu into W minus mu into P sin theta. So now mu W is equal to P cos theta plus mu into P sin theta. So now you have to take P. P is equal to mu into W divided by cos theta plus mu into sin theta. So what is mu? Mu is equal to tan phi, that is the angle of friction. So now you have to substitute tan phi into W divided by cos theta plus mu sin theta is equal to P. Tan phi, again you can write as sin phi by cos phi. So it is equal to sin phi divided by cos phi into W divided by cos theta plus sin phi by cos phi into sin theta. So now you have to take W sin phi by cos phi divided by cos theta cos phi. You are cross multiplying this plus sin phi by sin theta divided by cos phi. So cos phi get cancelled. You are getting W sin phi divided by cos theta cos phi plus sin theta sin phi. So now this is equal to P is equal to, so here onwards P is equal to W sin phi divided by this term cos theta cos phi plus sin theta sin phi is cos theta minus phi. So now in the question you have to prove that P will be least if angle theta is equal to angle of friction. Angle of friction is phi. So P will be least. This is equation for P. P will be least when the denominator is maximum. When the denominator is maximum. That is cos theta minus phi is equal to 1. Maximum value of cos theta minus phi is 1. That is theta minus phi is equal to 0. So you can write theta is equal to phi. So thank you for watching. You have to copy all these questions in your notebook. Thank you.